Lesson 103, dividing radical expressions. The first type of problem we're looking at is rationalizing the denominator. So what does it mean to rationalize? It says to rationalize, use a method to remove radicals from the denominator of a fraction. You've already learned this year that if you multiply a radical by itself, so a radical times a radical, it removes the radical symbol. So the square root of 4 times the square root of 4 is 4. In this example here on the screen, you see square root of a divided by b. You can rewrite that as the square root of a divided by the square root of b. And to get rid of the square root of b in the denominator, you multiply it by the square root of b. And whatever you do in the denominator, you must also do in the numerator. And then you can simplify it from there. So rationalizing it just means to get rid of the radical in the denominator and then simplify. So let's look at an example here. Here we have the square root of 7/3. Anytime your radicand is a fraction, you need to rewrite the problem with a radical in the numerator and a radical in the denominator. So that's what they did here with the square root of 7 times divided by the square root of 3. And then to get rid of the radical in the denominator, they multiplied the square root of 3 times the square root of 3. And whatever they did in the numerator, they must do in the denominator, they must do in the numerator. And so the square root of 3 times the square root of 3 is the square root of 9, which the square root of 9 is 3. And then the square root of 27 times the square root of 3 is square root of 21. You cannot simplify that any further. So your answer is square root of 21 over a positive 3. So let's work through a problem ourselves. So here I have the square root of 15 halves. I need to rewrite that so I have a radical in the numerator, so square root of 15, divided by the radical in the denominator, square root of 2. Here I need to get rid of the radical in the denominator. In order to do that, I need to multiply it by itself, so the square root of 2. Whatever I do in the denominator, I must do in the numerator. So when I do that, I end up with square root of 15 times square root of 2 is the square root of 30, divided by square root of 2 times square root of 2 is 2. I cannot simplify that any further. I cannot reduce 30 in 2 because that's a square root of 30, not a whole number 30. So you cannot reduce a radical and a whole number. Second example, square root of 5 divided by 3. So I need to rewrite this as a square root of 5 divided by the square root of 3. To get rid of the radical in the denominator, I must multiply it by itself, which is the square root of 3, multiply the numerator by the square root of 3. That gives us an answer of square root of 15 divided by 3. Again, since I have a radical in the numerator, a whole number in the denominator, I cannot simplify them both, so this has to stay as my answer. The next type of problems, you're doing the same thing. The only difference is now there's a variable in the denominator. So let's take an example for one ourselves. Simplify the square root of 7 divided by y. All variables represent non-negative numbers. Okay, so the variable in the radicand can never have a negative number in it, so that's why they're just stating that. If I rewrite this, this will be a square root of 7 divided by the square root of y. To get rid of the radical in the denominator, I must multiply it by itself, so the square root of y. Whatever I do in the denominator, I must also do in the numerator. So I end up with an answer of square root of 7y divided by y. Again, since the y in the numerator is in a radical symbol, the y in the bottom is not. I cannot cancel them out. This would be my answer, all assuming that y still cannot equal 0. The next one, simplify square root of x 11 over x. Rewrite this as square root of 11 over a square root of x. Get rid of the radical in the denominator. I multiply it by square root of x times the square root of x in the numerator. That gives us an answer of the square root of 11x over x. And this would be our answer. The next type of problems, simplify before rationalizing. So we have to break down the radicals first, then we need to simplify. So let's look at an example here. I have 2 times the square root of 50 y to the 6th divided by a square root of 28 y to the 5th. My first step is to simplify the radicand. So in the numerator, I have 2. I also am multiplying that by the square root of 50. I can break that down as the square root of 25 times the square root of 2, that's 50. And then the square root of y to the 6th, I can break that down to be square root of y cubed times the square root of y cubed. The denominator, square root of 28, that's the same thing as saying the square root of 4 times the square root of 7. And then the square root of 5, square root of y to the 5th, I can break that down as square root of y squared times the square root of y squared times the square root of y. Because y squared times y squared is 4. Y to the 4th times y is y to the 5th. When you multiply like bases, you add the exponents. Now I just simplify from there, so breaking those down even further, square root of 25 is 5. Square root of y cubed times the square root of y cubed is y cubed. So now I have 2 times 5 times y cubed is 10 y cubed times the square root of 2. And then the denominator, square root of 4 is 2. Square root of y squared times the square root of y squared is y squared. And then all I have left is the square root of 7y. Now from this point, now I have to get rid of the radical in the denominator. So I multiply this by square root of 7y. I don't need to do anything with the 2y squared yet. I just want to get rid of the radical symbol. Whatever I do in the denominator, I must also do in the numerator. So multiply that by square root of 7y. When I do that, I end up with, in the denominator, square root of 7y times square root of 7y is 7y. So I have 2y squared times 7y. That gives me an answer of 14y cubed. And in the numerator, I have 10y cubed times the square root of 14y. Now I can simplify. For my answer, the y cubes cancel out. I can divide a 2 out of 10, that gives me 5. Divided 2 out of the 14, that gives me 7. So that gives me 5 times the square root of 14y divided by 7. And this would be my answer. Let's look at the next one. Square root of 6x to the 6th. I can break that down as a square root of 6 times the square root of x to the 3rd times the square root of x to the 3rd. Remember, if the exponent is positive, just split it in half, and that's what your 2 radicals would be. And the denominator, square root of 27, I know a perfect square is the square root of 9 times the square root of 3. That gives me 27 times the square root of x. So now if I were to rewrite this, now I have x cubed times the square root of 6. And in the denominator, I have 3 times the square root of 3x. Now, in order to solve for this, I need to get rid of the radical. So I need to multiply this by the square root of 3x, multiply the numerator by square root of 3x. So now, square root of 3x times square root of 3x is 3x. 3x times 3 is 9x. The numerator, I have x cubed on the outside. 3 times 6 is the square root of 18x. And I know I can break this apart even more because I can take square root of 9 out of square root of 18. So this would be rewritten as x cubed times the square root of 9 times the square root of 2 times the square root of x all over 9x. So my next step is to simplify the numerator. This gives you 3, so I have 3x cubed times the square root of 2x all over 9x. Now I can simplify. I know I can divide a 3 out to give 1. Divide a 3 out here gives me 3. I can take 1x out in the denominator. I can take 1x away in the numerator. So now I have x squared times the square root of 2x. This is all over 3. And this would be my answer. And the fourth type of question, conjugate to rationalize. To conjugate an irrational number means to put it into the form, if it's already a plus the square root of b, the conjugate would be a minus the square root of b. Because you have a binomial here, a plus the square root of b, and you have another binomial here, a minus the square root of b. If you multiply those two together, you will get rid of the radical symbol. So you're basically squaring the a and you're squaring the b, and your answer is going to be a subtraction. So it'd be like finding the difference of 2 squares. Okay, so you're just going to change the sign that's in the middle. So if one was positive, the conjugate is negative. If the original was negative, the conjugate would be positive. So let's look at an example. Simplify 2 times divided by the square root of 3 plus 1. So here I'm going to rewrite this. Square root of 3 plus 1. The conjugate of square root of 3 plus 1. I need to get rid of the radical in there. So I need to have an opposite sign of the radical. So here, I'm going to rewrite this so I have the radical second, because that will make it a lot easier. So it'd be 1 plus the square root of 3. Now to multiply by the conjugate, it would be 1 minus the square root of 3. Whatever I do in the denominator, I must do also in the numerator. Now I can multiply. So I know the middle terms are going to cancel. So I just have to square the first term and the last term. So let's just FOIL this out. 1 times 1 is 1. 1 times the negative square root of 3 is a negative square root of 3. Positive square root of 3 times 1 is a positive square root of 3, so they cancel out. Square root of 3 times a negative square root of 3 is a negative square root of 9. Square root of 9 is 3, so this is going to be minus 3 in the denominator. And in the numerator, I just distribute. So this is 2 times minus 2 times the negative square root of 3, so that would be a negative 2 square root of 3. To simplify this, I end up with 2 minus 2 square root of 3 equals a negative 2 in the denominator. Now if we look at that part, we can simplify this. I know I can factor out a 2 in the numerator. If I take a 2 out, I have 1 minus the square root of 3. And in the denominator, I can take out a 2. That leaves me with a negative 1 on the bottom. The 2's cancel out. If I'm dividing by a negative, I'm just changing all the signs up here. So it's really going to be a negative 1 plus a square root of 3 as my answer. Let's look at the next example. Here I have 3 times this divided by the 5 minus the square root of 6. So I need to multiply this by the conjugates. So if I have 5, I need to get rid of the radicals, so I got the conjugate would be a positive square root of 6. So I do the same thing on the numerator. So all I have to do is square the first term and the last term. So 5 squared is 25. Put my minus sign down. Square root of 6 squared is the square root of 36, which is 6. So that's my denominator. My numerator, all I need to do is distribute. So I have 3 times 5 is 15. 3 times the square root of 6 is 3 square root of 6. So when I put them together, I have 15 plus 3 square root of 6 all over 25 minus 6 would give you 19. So you can keep this as your answer. You do not need to factor that out. You may, if you want to write it as 2 separate ones, you could write it as 15/19 plus 3 square root of 6 over 19. Either way works. Your assignment for next time, lesson 103, numbers 1, 4, 8, 13, and 18.